everything in the universe revolves around a central element, something fundamental at its core that holds it together, something that takes it further, something so powerful that it drives everything around it, creating new possibilities along the way. This is NavVis VLX3. Two 32-layer LiDAR sensors enable comprehensive and thorough reality capture. Groundbreaking, robust SLAM algorithms power accurate data capture in indoor and outdoor environments. 4 cameras on top of the device take high-resolution, sharp images for a complete 360 panorama. A built-in, intuitive interface displays live scanning feedback to ensure no areas are missed. And a unique, compact design allows the device to fit into a protective case or backpack for easy transportation and setup. NavVis VLX3, the new cornerstone of reality capture.
All right, good afternoon, everybody. Thanks for joining in today for the virtual panel discussion. With me today, we have Ryan Kuhn, Brent Slawnikowski, and Trevor Tyson. I'll go ahead and let them do some self-introductions, starting with Ryan Kuhn.
Hey, Matt. First off, thank you for the opportunity to speak here. Thank you for everybody who's listening virtually. I think it's going to be a great roundtable discussion. Like Matt said, I'm Ryan Kuhn. I'm the district location surveyor at District 1 FDOT.
Brent.
Thanks, Matt. I'm Brent Slawnikowski. I am with NavVis. I'm the account executive here in the Southeast, and looking forward to the discussion with you gentlemen today. And thanks for everyone who's joining in with us during their hopefully lunch hour.
Hi, I'm Trevor Tyson. I'm one of the mobile lidar and lidar leads here at McKim Creed, and really like to really like what I do, and like to show off some of the lidar technology, how it changes how we collect data, how we manage through projects, how we work through situations that's maybe untraditional, and really make a neat situation and product, and try to make things better sooner than later.
Awesome. And I'm at LaLuzerne with McKim Creed. I oversee our geospatial remote sensing group as well as business development for McKim Creed. And really appreciate everybody hopping on board. What our goal today is to really to talk about how technology can improve emergency response timelines, increase safety, decrease risk, and how the surveying technology is benefiting the public through, innovative uses, applications, and going from there. So I'll be your moderator. There is a opportunity to ask some questions in the chat box. So we'll probably reserve a lot of that towards the end, but I could hop on if some are pertinent to the topic we're talking about. I'll go ahead and ask the team. So looking forward to that interactive communication with the audience, and let's go ahead and get started. Ryan, I want to start with you. Can you, as a municipality and owner of a large transportation network, can you describe some of the responsibilities that FDOT has in getting the state transportation, the infrastructure back up and running after a major event? What does that look like?
Yeah, and good question, Matt. So everybody probably listening, if you're in the state of Florida, you're a stake and a shareholder in our corridors. And so historically, surveyors have usually been boots on the ground, first ones in, right? And so us putting on this hat as somebody who's first in on a response, it kind of almost comes second nature to us. Never more apparent than after Hurricane Ian were some of the things that we can do better, not only as an agency, but as a surveying and mapping and a geospatially minded group. So what we did is on a state level, we put together a drone response team. And so from an FDOT standpoint, we have those staff members, men and women, ready and trained to go out and deploy on those missions. And one of the things that they're going to do is to assess. All right, they're first in, and so we get to assess. But one of the unique things about the way that the technology is expanding within our profession is the fact that we can now stream back to a multitude of people. So there's eyes throughout the state really who can assess from different vantage points and different perspectives on the same image, right? So we can fly video, have it streamed out, and we have a multitude of eyes, looking at it. So from a department standpoint, we have that. We also have wonderful consultants who we can task to go out and do it, and do different things. And that's exactly what happened on this Hurricane Ian response, is the fact that we had a great team. One, it always starts with a great team. And from the FDOT side, we had a wonderful PM. Katie Sherrard was there. Wonderful knowledge, was able to take hold of the situation, give directions, right? Because you can have a bunch of people, but there's chaos without direction, right? So she was able to do that. But from a geospatial standpoint, what we were able to do is implement a good team that was multifaceted in their approach. And so conventionally, we've always thought of surveyors, geospatial professionals as boots on the ground. But that's changing, right? And we're evolving as a profession. And so we have different tools in the toolbox. And one of the things that was highlighted, especially in this response effort, was the tools in the toolbox being used in the correct way by the correct personnel and combining it to make a cohesive product that downstream we have good data to build from, right? That entire thing was wrecked, and we were able to take a multifaceted approach through consultant partners and direction and really put that together and combine all the different toys, right? We call them toys, but they're actually tools in the toolbox, regardless of the label that you place on them. And when we do that, you get a good finished product. especially when you have good leadership and cohesion.
Okay. And with that responsibility, is that a localized district responsibility, or is there a lot of interaction with statewide, like agencies?
Especially with something of this magnitude, complete statewide, and you've seen partners all the way from the Panhandle. Every district came in to help as far as DOT, and we also had a multitude of consultant partners throughout the state. So really, it was very evident early on, this is not a little task to overcome. And so management, Katie, those around her said, hey, look, we need a bigger response than what we're used to. And really, as a surveyor and a geospatial professional, I think it was, awesome is an overused word, but it was really awesome to see us as a profession kind of expand out of the box that we've always been put in, right? The perception is always that, hey, we support civil functions and that's it. And now what we've been able to do, not only through this response and through the different technology that we have emerging that we're capable of using and integrating, is the fact that we serve a multitude of other disciplines, right? And so this hurricane highlighted it, and really the response showed, and it's not just local. It was able to take one vision, one expectation, take a multitude of inputs from different teams, different consultant partners, and in-house, resources to come up with what was the final product.
Okay, no, that's appreciate that insight there, Ryan. So to add on to that, Trevor, as a consultant, how do you prepare to meet some of those requirements from the department in leverage technology or streamline ways to get that information as quick as possible to the public?
All right, so this project was pretty unique. We got a phone call and we kind of hit the ground running, and you think any other project, we do them day in, day out. We drive down the road, we survey roads, we survey sites and things like that. But the unique component in these cases of the hurricane response is we didn't know what we were getting into. We didn't even know if we had hotels for people to stay at, where they were going to get food, fuel, things like that. So, to do our job, what tool is going to be the right tool? So the NavVis and the drones kind of gave us that first insight, or that first look into what we were getting into. It's easy to map a road, right? You got the edge of pavement, you got the curb, you got the drainage structures, but they're not there anymore. So how do you build a product? How do you go out and take a traditional method, something you do every day? We're professionals, right? And how do you do that when it's irregular? So obviously LiDAR and the NavVis was a great tool for this, because it was able to capture the irregularity. So, and to tie to Ryan's point, we could communicate that back to the engineering groups. It's like, well, we can't give you the same product we always give you because it doesn't exist. It's not possible. So what do you want to start with? How do you want to get there? Overall, we were able to take the NavVis out there and the drones and kind of get the assessment, and we still were able to complete the product in a relatively short timeline, overcoming those obstacles. But I want to say between 45 days from notice proceed to a product that was used for some of the temporary rework, some power line, some of the power restoration work. Getting just emergency vehicles and construction vehicles in, seeing what obstacles they're going to overcome, just having this data be able to relay it is amazing. So that was some of the challenges that were just different than what we're used to, and having these toys, that's the way we look at them. I mean, we do this for a living, so we like to need new toys to us, but they're really tools that change the whole procedure and how we approach this project.
Yeah, that makes a lot of sense. And with that, so it sounds like the state has a lot of requirements and needs for consultants to adhere to. Consultants have to jump through. There are obstacles to get some of this stuff done. Brent, how does the manufacturer of equipment help solve all these different challenges? That you have needs coming from state agencies as well as consultants that have to help deliver. What does that look like from a LiDAR and imagery collection platform? Where do you see that technology moving forward with your group, and what do you do to prepare?
Yeah, I think, in terms of situations like this or any other emergencies, the local representatives are obviously keeping an eye on things and, might be checking in with resources within the company. Like, hey, we might see an increase in need for technology deployment in these regions due to a catastrophe or some event happening. So there's some planning behind the scenes to make sure, we're ready. Many of us have our own systems at home. There are times that in the past I've, helped out with situations, as a vendor, right, to help with these recovery efforts. So you might see that with some of the manufacturers. And then, we work with a variety of different municipalities and clients that have different requirements, different needs, different contracts. So it can get rather complex. So in situations like this, where we do have to deploy quickly, we're putting all of our resources together that we can to try and move through, the paperwork to mitigate, any lost time in these situations. And then, from that, you always learn from these events, right? I think Ryan mentioned that earlier. There's a lot they took away from this. And those are the things we look at to improve, not just in these critical events, but going forward for, any new client or any existing client that's looking to acquire technology, trying to streamline that situation and make it a little bit easier to get the technology in their hands. Everything from not just getting your equipment, but the training, right? Having the right personnel out there, being comfortable and confident with the technology. That's something we pride ourselves here at NavVis on. And, in situations like this, again, we're looking at ways to, do we have resources that we can deploy or be ready so that we can speed up training process for someone that might need our gear. So that's some of the things that we would typically see and what I've experienced over the years in sort of the sales profession.
Okay, that makes sense. And I like that you talk about the workflows, specific procedures, trainings, and confidence in the technology. Ryan, how does an emergency response situation like this, how does the department adopt technology that may not be procedurally mapped out in its entirety to have an all hands on deck approach? Like, where is there's obviously a reliance on consultants knowing what they're doing, but also what does the department do to help back check or validate that we're still meeting the end goal, but it may deviate a little bit from your traditional type of a survey approach?
And Matt, it's a really good point, because what we have is we have a big picture, and what we try to do is break it down into smaller groups, right? Any large thing, we're going to break it down and then just systematically go one by one. And so what we can do is say, hey, this is the end product. We got to it because we used means and methods A, B, C, D. So what we'll do is like any good surveyor, we know that there's a good paper trail and there's good workflow involved. So, making sure you got the right team in the place to succeed, right? We talk about having a team, but putting those people in the positions to execute and succeed is one thing from a managing standpoint that really makes sense, right? And so our management puts subject matter experts in place. Katie did a great job of saying, hey, reaching out to Hawk Myers and myself and saying, hey, look, who's best suited to be in what position? And we try to put those people in the positions to excel and to check it on the backside, right? They're professionals, and these individuals and these companies know what they're doing with a long history of doing quality work. But what we do to break it down on the backside is to do the QA/QC. Is just break it down into smaller bite-sized chunks. You eat the elephant one bite at a time, right? And so we say, hey, here's how we check the mobile LiDAR. Here's how we check the NavVis stuff that came in. Here's how we check the conventional, but it all starts with good quality control. You know, we talk about horizontal, vertical control. How'd you get there? And then what was derived from it? So really, we talk about that, and we talk about the provenance of the data. You know, how was it derived? How did we get to this thing? And then that tells us the level of accuracy, and it tells us what can be done downstream with it. You know, and it's really all about the user and what the user needs. There's a big difference between us going in and doing a design for new roadways or to repair existing stuff than it is to say, hey, I have a brush pile for debris. What's the volume of it? So, right. So we're the ones who are best apt to tell that version to say, hey, here's the data that you have. Here's the accuracy level that you can expect from this data set. And then move forward with that. But I think from a QA/QC standpoint, Matt, there's really no difference, right? We just need to make sure that we're stewards of the provenance. And that way, no matter the data set or the quality, we can be stewards of it downstream to let them know, here's what you can expect.
Yeah, that makes a lot of sense. Trevor, I wanted to ask you, what kind of safety approach does different styles of geospatial technology allow not just the field staff, but the public in these kind of environments that they're, post-event, there's a lot of chaos, it's a different environment than the normal physical locations, there's some destruction, things like that. How does that technology help you and your staff finish a project while increasing safety?
Well, from the safety aspect, I mean, first and foremost, taking in the drones or taking the NavVis and being able to walk around these structures, we don't have to get right up on top of the debris piles. We don't have to get in areas that we can have falling material, bridges, things like that. We can, what we do in LiDAR is all remote sensing. So we can stay at a safe distance and still capture the necessary tie-in points, the necessary data to map and build our products. So it allows us to kind of stay in a safe environment. It's no different than surveying from the side of the road or from staying on the shoulders and staying in the medians as a traditional surveyor. But now we can even come in areas where there's really very questionable safety concerns all around. I mean, it's not just the falling debris, it's what is in the debris piles. As you're walking through the water there, trying to get some of the shots back on the shoreline to see what the seawalls were doing and things like that. It was, it was a major concern. So if you're just, you're more strategic where you're setting up, you can take the time. It's a quicker capture too. So we don't have to, really huff it through, if you will, as a surveyor trying to collect so much in a day. We can strategically move around and stay and identify those safe locations. So I hope that kind of answers where you were going with that.
It does. And to add on to that with, remote technology. So, the safety comes from, if there's an exposed utility wire, you're not going to touch it with traditional survey equipment and using, remote technology. How does that affect your accuracy on a project? Are you still able to obtain survey grade, design grade accuracies with those kinds of methodologies?
Absolutely. Like Ryan said, it kind of boils down to your control. The technologies out there in all the remote sensing softwares. I mean, right tool for right job, obviously. When you're looking for the accuracy, every tool has its limitations, but we actually can capture more data and actually have more overlapping information that would validate the accuracy as you go through the project. So more data capture we have, the more redundant accuracy checks we have going through the data as well. And I actually want to take a quick look at this little slide here that we're sharing. And this was a little bit of a neat one. So this is actually with one of our static scanners, and we're actually showing that diving into the accuracy where you look at the top left of the little image up there, you can see where one scan kind of popped out from the rest. So we were able to identify and really tie it back down using a cloud-to-cloud adjustment, things like that. And then we have the control reports, which tie right back to your traditional survey control and accuracy. So the technologies we're using definitely still preserves the accuracy that you would get with boots on the ground traditional survey methods.
Yeah. And Brent, how does the SLAM technology come into play in these kind of environments? I mean, it's kind of a close quarter, there's houses, debris, things like that everywhere. How does the SLAM technology help to produce a product?
Yeah, I think, to bounce off a lot of what Trevor said, one of the key elements to, maintaining the safety and everything, and it's been this way for many years, is LiDAR, right? Whether you're working in these almost construction site-like conditions or areas where things are exposed that you can't see or feel, being able to maintain that distance is crucial. And deploying the technology you guys did for this situation was exactly what I would see. But going back to talking about the SLAM, right, and the conditions we're working in. So depending on, there's a variety of SLAM systems out there. Some of them integrate GNSS, some of them don't. NavVis is one that doesn't. It's really just understanding the tool, right? Ryan mentioned earlier, having the right personnel, having the right training, right? So understanding the limitations of the technology. So in the situation that you guys were in, using the SLAM with VLX, as long as we have vertical geometry and it's within that working SLAM range, you should be able to confidently and accurately scan that environment with good control. You can use VLX with or without, but we always recommend using control. It's always going to be that way to quality check your data and ensure that you're working within the limitations of the equipment as well as what your client expects. There were probably situations, that this is a somewhat challenging environment with the water because you have an open space, not a lot of geometry to bounce off of. Mm-hmm. So you have to really plan out, how you're going to attack this. Is it going to be a combination of technology, using drones, using the RTC, using your NavVis? So having a game plan going into that situation ahead of time is certainly going to help. One of the things I love to talk about when it comes to safety and working with the NavVis is, a lot of people kind of give you weird looks for its form factor. But one of the things I love about it is the way it's really designed is to allow people to really pay attention to the environment they're working in, right? You have a screen to be able to see the data, but your eyes should be up. You should be watching where you're going, observing the environment around you. So it really allows for that. It still allows for you to maintain 3 or 4 points of contact as you're scanning, whereas other devices may not allow for that. And then also working with some of the terrestrial laser scanning systems, getting into these very unique setups can be challenging because you don't know if the foundation's stable. You don't know if this area we're seeing in the imagery right now, if I could set a tripod there. Yeah. So can I scan that, from a distance from a different area, or can I walk around that environment carefully and have my hands free using the VLX and be able to capture all the detail I need to use that further downstream?
Oh, that's great. And Ryan, as an agency, how does the public and their safety come into play? I mean, you're deploying consultants and in-house staff on site. Communications are probably knocked down. There's a lot of different factors and variables in this kind of post-storm event or post-event environment. What does that look like from a public safety, and how do you want that? How does that integrate into your day-to-day?
Yeah, that's real good, right? So we have a storm come through. Everybody wants to get back, right? You have a multitude of people. One, you have people who want to get back to see, hey, I have a house there. Let me get back. You have storm chasers. You have just looky-loos, right? So you have a bunch of different people who are trying to try to go down the corridor. There's already stuff down, right? You talked earlier about down utility lines, debris. But once we get the debris, once the cut and toss crews come through and we have a quasi open roadway for, shareholders to get down. Now, what we don't want to do is put 15 field crews with a prism set up on the side of the road. So then that way, every 1,000 feet or whatever, we got 4-man crews just out there collecting data. That really what that does is it takes this safety corridor that we're trying to create, and we're just putting more stuff in there, right? We talk about the motoring public driving and what's catching their eye, what's keeping their eyes off the road. Those surveyors being out there, especially in that environment, they're detracting, right? And so we want to keep that corridor as safe as possible. So we implement technologies like this. We take these kind of tools and toys, and we can take 1 or 2 crew members, get them out of that safety corridor, get them collecting data, and then we bring it back to the office. So at the end of the day, we're achieving the same thing, which is gathering data to put together a good product so a multitude of users can use downstream. And we do that without people in the corridor. And so that's the ultimate goal here is, one, we have moms and dads who want to go home to their families at the end of the day. And that's the number one reason that we do what we do, irregardless of whatever the narrative is. That's the truth. And we can accomplish that by getting them out of the road, using this technology to gather data and get it back and get it processed. So, of all the things, of all the bells and whistles and all the marketing that tells us here's what this technology does, I've been in it for, 27 years now. The technology brings safety. And the technology brings the fact that we can send our staff members back home and we don't have to hear about a fatality on the news. And so that's exacerbated when you get into these kind of high stress situations where there's a multitude of people who are coming through. We don't know where down power lines are. So the more variables you throw into the equation, the more dangerous it becomes. So we use these kind of technologies to mitigate all of that.
Well, appreciate that. And speaking of, using those technologies to mitigate those situations, if each of you had a crystal ball, what does this look like in another 15, 20 years? I mean, the geospatial technology is going, it's incredibly improving year to year. So Brent, can I start with you? Where do you see this going in helping with these real-time post-event type situations? Like, where do you see technology heading?
Yeah, so let me talk a little bit on the software end, right? I didn't talk a lot about that, and I know both Ryan and Trevor alluded to it, but being able to make quicker decisions and being able to have data checks, right? I know one of the things that I got to witness during the storm, which I was on the other side, so I didn't get hit by it, but where I was at before, we were doing captures for some insurance claims, and, that data was being looked at constantly as it was being uploaded. So there's been this transition over the last couple of years, and it's kind of a, some people don't like it, some do, but we're kind of heading that way to the cloud. And it's a blessing because of some of the capabilities it allows us to do, right? It allows people at the offices that are hundreds of miles away to be checking our data as it's coming in, because we don't have those resources to do that on site, especially in a situation like this, right? Mm-hmm. So what I think from the manufacturer perspective is we're going to continue to see that software push, that software development. Things become more streamlined. Things become more easier to bring the data together, right? A lot of the solutions you guys are using today are from different vendors, and some of them play nice together and some of them don't. And I think as a vendor, that's something we recognize, and we want to make it easier for our customers to be able to bring different data sets from different technologies together, because we know that each of our solutions doesn't solve 100% of the problems, right? So I think that's what we're going to continue to see from the software side. On the hardware side, I can't imagine what a VLX looks like in 3 to 5 years. The form factor is as crazy as it is now, and that will continue to evolve. as we go forward. So what we'll look for is, the number one thing is listening to you guys, you telling us directly, what you like, what you don't like, what things need to be changed, kind of separating the needs from the wants, right? We all have a lot of wants and these somewhat realistic or unrealistic feature requests that, we see from time to time. But the number one thing that, our clients can do for us is be communicative to us and let us know what are the things that you need to make your job easier, safer, faster. We're doing that. NavVis has done a great job over the last several years of really pushing that. But the number one thing is you guys and your feedback. So I think we'll continue to see accuracy improvements, right? SLAM get better and better and maybe become that, what we see TLS scanners as today, or some new technology. Who knows? But that's what I will continue to do, and what I would love to see our reality capture community do. And we appreciate everything that everyone's been doing so far.
No, that's great. Go ahead, Trevor.
Yeah, so one of the things, as he was just talking about, the multi-sensor approach, just kind of add to that, we had a plan going into the Sanibel, and I was showing you some of the Ivion material there. And one of the plans were we're going to scan a parking lot, right? We're going to take a TLS scanner out there. We're going to scan that parking lot. No big deal. We do it a billion times. Well, once we took the NavVis out there, we saw that there was sand at all the design features. So a static system, we would have sent a crew out blindly. They would have gotten the data back, and we're like, okay, let's go back out there with boots on the ground. So that multi-sensor approach is still something that, like you alluded to, it's always going to be there. But having some of these other technologies to help make those decisions before we in this case waste our time or the public's time and money and just to capture this information, we can use this cost savings across the board and time savings. Talking about people coming into the corridor after the storm. I hope you saw some of those locations. If you were to see that, and I encourage you to take a look at Google Earth and see what it used to look like. There were houses lining up and down this road. There are people who are trying to get back who don't even know if they're get back home, that don't even know if their home existed. So it was just a heavy magnitude. And like I said, the NavVis was a good insight, good tool to kind of give us that perspective on the ground. So.
Yep. And man, I'll go ahead and finish it up. 15 years is a long ways down the road. I'd like to back it up. The good thing that's being recognized is the fact that we don't need proprietary information, right? We need everybody to play nice together. And there's only so much. There's a reason it's proprietary, right? There's a lot of time, resources, and investment in it, and it gives them an edge in the market. But at the end of the day, the edge in the market kind of falls off if you're the only one who plays nice by yourself. So, making things non-proprietary is a big step. We kind of see where it's going with the multispectral collection methods, right? We're already getting used to workflows that integrate them all together. Mm-hmm. I think the biggest thing, just a different perspective on it, I think our legislation is a major hurdle right now. I think that once we get through some legislative hurdles, we can get some things cleaned up, some misconceptions, and maybe, get a little bit more organized to get some of these hurdles taken care of. Mm-hmm. I think there's going to be an exponential growth once we can get some of those hurdles out of the way from an FDOT corridor standpoint, right? We have the private side's doing a bunch with it, which is really good because there's a lot of testing and tuning that's happening, and they're working a bunch of the bugs out. I hear it throughout the profession. Hear great things, and I'm excited about the fact that hopefully soon we can get some of these legislative roadblocks out of the way. For me, that's what it looks like. I think the puzzle pieces are there. One of the things that we do a good job of in our profession is taking these puzzle pieces, putting them together, making a picture, so then everybody else downstream gets to have that picture, that viewpoint, that vantage. One thing that I think that's been kind of overlooked up until now, and hopefully, Matt, I'm not stepping on your toes and you're not going to circle back around. If so, you can slap me on the wrist. Is with all of these different sensors and the things that we're doing, it does twofold. One, it allows engineers, designers, everybody downstream to take you back to that day in that place, right? As time evolves, as things happen, changes happen, that captures that moment in time and lets us say, hey, this is really what happens. That's good from a moving forward standpoint. The other side for us, right, not only telling the story as geospatial professionals, but also from an FDOT standpoint, when that thing hit Sanibel Island, do you think people in Green Cove Springs were really worried about what was happening there? Do you think people in Pensacola were too worried about what happened? And I'm sure they were worried, for people who were involved, but they don't have something that's tangible. And so what this does is this allows us to show all of these people, here's what it was like, and here's what we did. And this technology offers that like never before. We could take a survey that was done 15 years ago, and it's just lines on a paper, right? Now we've expanded it. Now we've expanded all the different disciplines that use our data. So from geospatial professionals, this kind of opportunity to tell our story and just showcase what we can do from a variety of standpoints is really good, because a picture is worth 1,000 words. We say it all the time, but you take a before and after picture of something like Sanibel and what's happening out there, that lets somebody who's not directly affected and not near the epicenter of this storm, and it gives them a sense of there's something been done there. My tax dollars, my efforts as a stakeholder and a shareholder in this department are being used well. So I think that's something that kind of gets overlooked.
Yeah, that's a good point, Ryan. And I also like how you mentioned that this technology does provide a snapshot in time. It also allows other individuals that are not local to the region to help work with the data. So you have this, so maybe Brent, you could talk about how using scanning and imaging technology allows a larger workforce that doesn't have to be local, and what are some of those challenges with that data transfer, things like that, because there are some areas where there's no power, very little connectivity. What are some of the ways to resolve that?
So I can recall during the storm where I was at before, we had crews staying in Lewistown, which for those of you on the joining our call who don't know where that's at, it's on the southern edge of Lake Okeechobee. That was the nearest areas where we could get hotels for our crews because areas were inaccessible, or you just couldn't get hotels because they were all booked, right? So it makes for a logistical challenge, and it's not just a challenge for NavVis; it's a challenge for all technologies, whether you're using cloud or you're computing your data locally. Again, we're not bringing $10,000 HPs or box laptops with us to these sites to process the data. Some of us, yeah, maybe we are, but a lot of times we're not. We're trying to get in there and capture as much data as possible. One of the things I was going to add to Ryan's point was the assessment, right? The assessment of these areas and trying to, keep as many people out of those danger zones as possible. This technology really helps with that, right? Whether it's assessment for damage or for insurance purposes or for road open or closures, etc., right? Trying to minimize how many people are in the area so we can assess it as quickly as possible. That's where these technologies really are offering huge advantages, right? And then that kind of stems into what we're talking about now, the data and how people are working with it downstream, right? So being able to have this data capture and share it and collaborate, whether it be locally or state to state or nationally, right? I can get that data in the hands of insurance claim adjusters. I can get that in the hands of my engineering team with the DOT or other engineering companies that are helping with restoration efforts. I can get that in the hands of personnel who are going to come in and get rid of mold and things like that, and understand what it's going to take to reopen schools or other facilities. So the challenge with all that in these environments is, yes, we have reduced telecom, we have reduced power, so we have to work around that. So part of that, and what I saw, was driving, an hour and a half away to a hotel, being able to upload that data there. In some areas where you do have telecom infrastructure that made it through the storm, being able to upload data via cell phone, right? It's not quite as nice as being able to connect to GNSS, where typically it's pretty easy to do that on a satellite as long as you have no canopy. But those were some of the challenges we saw. And I think what we'll continue to see as part of what we want to do is, how do we find ways to upload our data faster? How do we find ways to sort of truncate our data so that we can get it loaded faster or minimize? How do we shrink 2.4 million points per second into something that's tangible, right? I think most of us can say the days of sending hard drives are almost over. There are still some practices of that, but that's what we want to get away from. So what we'll see in terms of the developments and the changes is faster upload speeds through our telecom providers, smaller data sets from the vendors, and figuring out how we truncate that data, which means the data is getting in the hands of the people that need it faster for quicker decision making.
That's good. And just one quick follow up on that. Ryan, you mentioned, Brent, you mentioned it gives you a nice opportunity to really create surveillance of the area, or see what's going on. And Ryan, you mentioned the DOT had a lot of drones and things like that at the beginning. How does that capture, the imagery capture, LiDAR capture, that instantaneous capture of information allows the DOT to make better decisions? The decision-making process it's got to be quick. It's got to be right.
Exactly. Well, yeah, exactly. There's two things. One has to be correct, and one has to be done quickly, and with good sound judgment and decision making. And for me, I live in my professional career is surrounding yourself with good quality people, right? And so I think that with this collection method, it enables us to get that data into the hands of a multitude of people who are a lot smarter than I am, right? We can get that data set into people who can make decisions, but from a number of different perspectives, right? So we can look at we can get that video footage. Let's just use the specific instance of we went out, got drone footage. We flew Sanibel Island. Let's say we flew 5 miles of it. It's completely trashed. We're the first ones in. We fly it live, right? We can stream that video live. What that's going to do is, the more people that you can see, the more people that are seeing that, they're making decisions from their vantage point, right? We look at things from a survey vantage point. Traffic ops looks at things from traffic ops, right? Everybody's silo is the most important silo. Just ask them, right? So when we can get that data into everybody's hands, the conversation becomes bigger, and as long as it don't get out of hand, which Katie did a great job of mitigating all of these conversations to say, hey, look, everybody's got a silo. Everybody has a decision. Let's come to a conclusion, and let's get those decisions made, right? And so when you get that kind of data out there, instantaneous feedback, instantaneous snapshot, here's what's happening, cut and toss crews can start making a decision. EOC centers can start making a priority list. They can have a better idea how long it's going to take. Without that kind of imagery and without that kind of feedback and that data input, they don't know how long a cut and toss effort may take. But you get an EOC center involved, and you get somebody like Jessica White, who runs our Fort Myers ops. You get somebody like her involved in the conversation, says, hey, I can take a look at this corridor, it's going to take roughly 3 days for us to cut and toss. There's planning. Now we can say, hey, when those 3-4 days are up, here's where we can go next. You formulate a plan, then you execute the plan, right? Like with any good thing, we plan the work and we work the plan.
Yeah.
And so when we do that, good things happen if we execute. The best way to come up with a plan is to have the best input possible. This is the tool for that input. Having good, sound people in the room when the conversation happens is how the execution gets played out.
No, no, appreciate that response. I do see a question coming in. Let's go ahead and transition there as we're wrapping up our lunch hour here. This is for everybody. What is the most challenging part of combining these different technologies to provide a comprehensive solution? Trevor, we'll kind of start with you because I know you have a lot of influence on using anything from hydro to subsurface to aerial to different kinds of multiple terrestrial platforms. What does that look like?
Absolutely. I love combining technologies. It's really neat to see the details change with the different technologies. I'll give an example of aerial to mobile to static. You can just zoom out and see the entire corridor, see what's happening 600 foot in a swath. And then you drive the mobile, and now you've got 200 foot of the swath. And then you want to get up into the bridge and just see the density change and how you can blend all that together. I love combining data sets. With that, there's a challenge, though, and the challenge usually rolls back to control, planning, and everything else. So control has to be built properly. It has to be checked, and it has to work. You do that, and you build those steps, and you have a plan to tie off of Ryan there. You can make that plan, execute the plan, and it comes together. If you try to go, one person that comes out there with a NavVis without talking to the person running the mobile, without talking to the person running the aerial, and then you got the guys scanning on the bridge with the static systems. If we're not talking to each other and tying into the same points, it's going to be a mess. You can get it close, it might look okay, but you're not going to be able to blend the technologies. So really, with that, the foresight and the planning, it comes together, and it's really neat. It makes a comprehensive picture of what's out there, a live model, or when I come out and say the most controversial term is the digital twin, right? It gives you that option to build what you want to build. I mean, whatever your interpretation is on digital twin, what it is, that, right? So, but having all the technologies tied to the same control, and I special place for all the surveyors laying out the control. It's not easy sometimes to keep everything hot and tight, but if it wasn't for them, it wouldn't be able to come together.
I appreciate that. And Brent, I'm going to kind of charge, we talked a little bit about open source data, and Ryan talked about that need at a state level. One of the goals is to eventually have, let's say, a statewide topographic map that also includes all the coastal hydro and roadway information, things like that. How does the manufacturers position themselves to be able to take away, cover up the logo on their shirt a little bit just to help provide that open source like that? That's a challenge. It's a huge challenge. What does that look like?
Yeah, every vendor, it differs, right, with how open they are with their API and things like that, right? That's why, in the SLAM industry, everyone's kind of got their own unique solution, right? We all have a little bit different algorithm, and nobody wants to share that, right? Because that's kind of the secret sauce. But then there's the other side of, I want to bring drone data into Ivion, or I want to bring VLX data into Pix4D or something similar, right? So I think, we'll continue to see more collaboration, right, amongst most vendors, I think. We certainly want to be able to ingest as much third-party data as possible so that it's easier for our customers to process, downstream. I think the same goes with open source data, right? We are, working with different third-party software vendors like TopoDot and Esri and others so that we can be cohesively bringing our data sets together, being able to streamline VLX data into the Esri environment or into TopoDot, where a lot of our users are doing their extraction. So what I want to see from us and other vendors is more collaboration and making it easier for our customers. And we have, us here at NavVis, we have a lot going on. We're, again, listening, We want to hear from you guys and what your wants and needs are, so that we can help prioritize those and get you working with more of those tools that you're already working with now in a more cohesive and streamlined manner.
Okay, awesome. We got another. I'm gonna jump to another question from one of our LinkedIn users. What was the timeline from scanning to final delivery? So, Trevor, I'll let you go ahead and tackle that one.
All right, so we actually had two projects that kind of happened at once. So I'm going to kind of rope that timeline together because we literally rolled from one project to the next one. So I want to say the first one we probably hit the about the 30-day mark, 1 to 30 day, and this is from notice of receipt, not boots to the ground. And I think we had the phone call, and then we were hitting the ground 3 days later. So boots on the ground, notice receipt. Sorry, 1 to. Let me kind of check out this slide a little bit. 1 to 10 days, we had done all the acquisition, right? We've gone out there, we've gotten crews, mobilized, collected the data, made any adjustments to our plan. And then 11/25, we started trickling through and getting some information out. One of the first things that was asked for that was kind of ahead of the other deliveries was, can you get us the location of where the power poles are so we can start restoring the power, so we can drive sheet piles to bring back the ground around the poles so we can have stable poles to drive in the ground. And then, we started doing the extraction. We started tying the conventional survey, the landlines, the alignments. SUE designates, even though as you saw from some of those pictures, the SUE is pretty designated because it was sitting on top of the ground because that's the only place they could put it. But that was that 11 to 25 days, and then the 26 to 45 days, it was taking all those individual components and start merging together, finalize the deliverables, provide some phase deliverables, and then start diving into more of the structural elements that take a lot more to engineer and design. But, we had to get to that point. So I would say about, 45 days for the duration on both of these projects.
Yeah, and Trevor, I appreciate that. And I see how you highlighted all the different elements of a project in that timeline, because 45 days may seem like a long time, but let's, Ryan, I want you to kind of chime in a little bit on, the district has existing control data, existing alignment information. A major weather event like this tosses that out of the water. I mean, they're obliterated monuments, so you're reestablishing stuff. What's the importance of going and building that base, that foundation of retracement data?
So from a profession, I'm going to try to keep it quick. So from a profession standpoint, the survey profession goes all the way back to Babylon, because when those plains will get flooded, all of it will go away. And so that's what we do. Like, we recreate things when havoc comes through. So in this case, it was super, super helpful and apparent that what we're doing works. Our approach works, right? We can go back and recreate as much of those references to the alignment moving forward. And as we move forward, we are exploring other opportunities to say, look, if all the monumentation went away, how can we put that back on the ground? And so from a state standpoint, from a 10,000-foot view, we're looking at that. And there's a great conversations happening with some brilliant minds who are out there on the cutting edge. And we have some solutions that we're sifting through. But this is a perfect example of where we're not quite to where we're looking at for the future. But what we're doing now definitely works, right? Anytime we can recreate an alignment like what was happened out there when just complete obliteration happened, it lets you know that what you're doing works. And so definitely different approaches help that, right? We have GPS, but what we're doing now works, and where we're headed is going to be even better.
No, I appreciate that. And you mentioned where we're headed. Where do you guys see AI fitting into the software, the analytical side? AI is such a big topic of conversation, so we only got a couple minutes left, so that'll force us to keep it short because we could probably do a whole nother.
I was gonna say I love your timing on that, Matt.
Man,
Yeah,
I was gonna say
let's toss it out here with 3 minutes to go.
Yeah, 2 minutes left, and we're gonna toss that one out there. Good job. I like the moderator.
Because I mean, we could literally do a whole virtual panel on where that's going, but
Maybe that's the next one.
do some highlights on how that'll impact from we'll start from a manufacturer's perspective because you're building the data capture equipment in some of the downstream software stuff. Then we'll go to Trevor, and then we'll wrap that question up on how that'll affect the owners with Ryan.
Yeah, I'll take 30 seconds. So we're already doing it here at NavVis. So you guys saw the rollout of image blurring right after the launch of VLX3. We're continuing to understand and listen to what other functionalities our customers want. We have other developments happening. I think, for this particular situation, there are some tools out there that I've seen and I've worked with that can help, speed up, again, the information that needs to get to the people downstream, right, so that we can make decisions. So I think what we're going to see from the software end is a lot of the softwares we all work with today, the Autodesk world, the Bentley world, the TopoDot, etc. We're going to see those functions start to come into play a lot quicker than we think. So we're listening and we're all doing it, right? So that's my view from the manufacturer side.
I'm going to try to keep it short to get us under there. So, I mean, really, everything we do is kind of semi-automated, and we're testing these tools on a daily basis. So it's just a matter of time before the AI does kind of consume over. At this point in time, where semi-automated is the main approach, but there's a few tools out there that are making it so you just kind of press the button and you get a pretty good answer. Still needs validation, always needs validation, but it gets you closer. So, I mean, it's technology to come.
Ryan?
Yeah, so for me in my seat, what I look at is I'll piggyback non-proprietary software, right? Software that anybody can get to, we can put stuff in, but garbage in, garbage out. So I think one of the things that we need to make sure that AI does, and maybe it's us as stewards of data, is provenance. Right? How do we keep that? How does AI doesn't know the difference between a point that has a 1 foot air ellipse and a 1/10 air ellipse? So I think maintaining provenance throughout a project, because then downstream AI can pull that out. So we're headed that direction. One way that we want to make sure we steered is to say, hey, how do we know good data from bad? Because really, we're the ones who dictate how good the data is. Somebody downstream gets a point cloud, they don't care. They just know it's a point cloud. They're going to start pulling from it. So let's maintain that integrity and then let it do its thing. So I'm excited to see what it holds and where we're going.
It's scary and exciting at the same time, right?
Agreed.
All right. Well, Trevor, Brent, Ryan, thank you guys very much for participating today. Really enjoyed the topics of conversation. Great responses, great answers, and the audience appreciate typing in some of the questions there. Feel free to reach out to me or any of us if you have any additional questions. Happy to help, and please stay tuned. I do anticipate more virtual panels coming forward from McKim Creed and some of our other technical industry experts as well. So thank you all very much, and this concludes the session for today. Take care.
Thank you.
Thank you.